It is time to do mole to mass problems. So what we're going to do now is take everything we did in our mole to mole problem and add one more step. So just like before, we'll read through our problem and start with the steps. So today we have 2.56 moles of nitrogen combined with hydrogen to form ammonia. How many grams will be produced? So step 1, just like last time, is to figure out what our equation is and make sure it's balanced. So nitrogen, N2, plus hydrogen, H2, yields ammonia, NH3. Okay, go ahead and balance this. We need to put a 3 in front of the hydrogen and a 2 over in front of the ammonia, which gives us 2 nitrogen and 6 hydrogen on each side. So there's step number 1. Okay, step number 2, we are going to take the information from the problem and then put our mole ratio in to switch to our new substance. So I am starting with 2.56 moles of nitrogen. Then to start with my mole ratio, moles of nitrogen needs to go on the bottom, so it goes away, and moles of ammonia will be on top. Now I need to look back at my equation, find nitrogen, our first reactant, and it does not have anything written in front of it, which means that the coefficient is 1, so I'm going to put a 1 right down there. And then we find ammonia, our only product for this reaction. It has a coefficient of 2, so we put a 2 on top of the line. Step number 3 is to change moles to grams. So I'm going to bring over our information from the previous slide where we already put our mole ratio conversion in, and now we are going to take that moles of ammonia and turn it into grams. So 1 mole of ammonia is going to go on the bottom, and then using information from the periodic table, I can calculate that there will be 17.0307 grams of ammonia in that 1 mole. So there's step number 3. Step number 4, our last step for this kind of problem, is to cancel and calculate. So I'm going to go through, cancel out my labels, see if I can cancel out any numbers before I pull out the calculator to figure out what our final answer is. So here we go, moles of nitrogen on top and moles of nitrogen on bottom cancel out. Then we have moles of ammonia on top and moles of ammonia on bottom, leaving us with grams of ammonia, which is our desired label. So that's good for the labels. I don't have any numbers I can cancel out this time. Both of our numbers on the bottoms are 1, so I can just go right to the calculating part. All of our numbers are on top, so that means it's all multiplication. I plug this in and end up with 87.197 grams of ammonia. So there you are, a mole to mass problem. If you have any questions, go ahead and either email me, send me a message in Schoology, or catch me at school. So, see ya.